Welcome to my video course on mastering ERTMS/ETCS signaling systems. Today, we're going to systematically break down the transformative advantages of modern European rail control. This is, without a doubt, one of the most significant leaps forward in railway engineering we've ever seen. We are finally moving away from century-old hardware and fully embracing a software-driven future. So let's dive right in. If we look back a bit, the European rail network was absolutely paralyzed by this incredibly fragmented patchwork of completely incompatible national signaling systems. Think about the sheer diversity of setups we had to deal with. You had LSAF in Spain, TVM in France, LZB in Germany. Every single time a train crossed a border, it practically hit a digital brick wall. Seamless international travel was virtually impossible, simply because a locomotive couldn't speak the language of the next country's tracks. So, here is the agenda for today's explainer, where we'll cover the universal solution to all that historical chaos. We're looking at 1. The ERTMS solution, 2. Seamless interoperability, 3. Increasing track capacity, 4. Enabling higher speeds, 5. Advancing rail safety, and 6. Reducing lifecycle costs. All right, kicking things off with Section 1, the ERTMS solution. You already know the ETCS component of the wider ERTMS program is a total game changer. It takes all that vital safety and operational information straight from the physical track side, those traditional green, yellow, and red traffic lights we're all used to seeing, and shifts it directly into the digital screens right inside the driver's cabin. This cab signaling approach is a highly standardized, interoperable system that finally puts every network on the exact same page, technically speaking. That massive digital shift leads us perfectly into Section 2, seamless interoperability. The absolute most crucial point here is true interoperability. By standardizing both the technical interfaces, meaning how the train actually talks to the infrastructure, and the driver's operative panels, we've essentially erased the borders. The screen a driver operates in Italy is the exact same interface they're going to see in Germany or the Netherlands. Because of this, trains can now cross international borders without the ridiculously costly and time-consuming need to swap out locomotives or change crew members just because the signaling system changed. And as a result, the deep integration of international rail traffic flows is absolutely guaranteed. We are linking high-speed and high-capacity lines across the entire continent on one single unified standard. We're essentially shrinking Europe, making the movement of passengers and vital freight smoother and way faster than ever before. Next up, Section 3, increasing track capacity, because this system goes way beyond just connecting countries. To really understand how we fit more trains onto the exact same steel rails, we gotta talk about how ETCS handles its data. By continuously streaming movement authorities to the train using the dedicated GSM-R wireless network, rather than relying on fixed physical block checkpoints, the system dynamically calculates the absolute optimal, safe distance between moving trains. It constantly knows exactly how fast the train is going, what its braking capability is, and precisely where the train ahead is located. And the results are just wild. Making the jump from conventional trackside signaling to this advanced cab signaling ATP system actually gives us up to a 40% capacity increase on the infrastructure we already have. Think about that for a second. 40%. Instead of spending billions pouring concrete and laying down new tracks, operators can basically conjure up virtual new tracks just by upgrading the software and digital signaling. It is by far the most economic way to dramatically boost how many trains you can run per hour. Which brings us to Section 4, enabling higher speeds. With those dynamic, computerized braking distances constantly crunching numbers in the background, we unlock unprecedented speeds. Now, when we talk about speed in rail, we're usually looking at 3 different metrics. There's your average scheduled speed, then there's the safe allowed regulatory speed, which ETCS Level 2 manages flawlessly every single day for high-speed commercial operations at 300 kilometers per hour. And finally, there's absolute capability, meaning the physical limit of what the system can safely handle. To put that physical limit into perspective, back in 2007, a specially tuned French TGV absolutely shattered world records, hitting an unbelievable 574.8 kilometers per hour. That is literally faster than some small airplanes. And it remains the highest speed ever safely managed and monitored under the ERTMS digital signaling standard. The system's processing is so rapid and so precise that it keeps a train perfectly safe, even when it's practically flying on the ground. Let's move on to Section 5, advancing rail safety. Look, managing massive trains at extreme velocities like that requires flawless, automated oversight. The real beauty of ETCS is how it completely removes the risk of catastrophic human error, like a driver missing a physical line-side signal in bad weather. Because the computer is constantly monitoring the train's speed against the track data, if a driver were to ever exceed their movement authority, the onboard computer steps in instantly and drops the emergency brakes. Combine that with direct surveillance of hazards like level crossings or avalanche zones, plus the ability to instantly beam temporary speed reductions straight to the driver's screen, and you've got a safety envelope that completely blows legacy systems out of the water. Finally, let's hit Section 6, reducing life cycle costs. You might be wondering, how does better, faster technology actually cost less to run? Well, it primarily comes down to wiping out physical line-side signals. When you don't need hundreds of heavy metal traffic lights out in the elements, you also don't need the thousands of miles of incredibly expensive copper cabling connecting them all. By making all that trackside hardware obsolete, and by opening the market to multiple competitive European suppliers who all use standardized digital components, infrastructure operators are seeing massive savings in both initial installation and ongoing maintenance. You get one unified system per track instead of multiple overlapping, hugely expensive legacy networks. When you take a step back and map it all out, the shift from hardware-heavy, localized signaling to a software-driven, unified European platform creates this incredible compounding effect. We get vastly increased safety, which allows for increased speeds, which gives us increased capacity. And it's all tied together with full interoperability, delivered at a reduced long-term cost. It really is an absolute masterpiece of modern infrastructure planning. So consider how this foundational digital architecture is going to enable even more automation in the future. As we move towards higher levels of ETCS, we're looking at a railway network that operates with unprecedented fluidity and intelligence. Just imagine the impact this will have on global logistics and sustainability as we move more freight and people off congested highways and onto hyper-efficient, fully digital rail networks. It's a fascinating evolution. Thanks, we can see you next video.